So in this title we have the following important points that we need to consider. So these are the following. So here we have, in this subtitle, we have rho value, which is mass over volume, and it is very simple. You know this from the lower grade also. So the other thing is specific gravity. So the specific gravity is, so first you need to find rho value of a certain substance, then you have to divide by the standard, and the standard is taken to be water at 4 degrees Celsius, and the rho value of water at 4 degrees Celsius is 1.0 times 10 raised to 3 kilogram per meter cubed. So the specific gravity is dimensionless, because rho of the unknown divided by rho of the known, then finally you'll get the specific gravity. So having this in mind, now let's have a simple example. So we have a solid sphere. The radius is given for a sphere. So in order to find the volume of this sphere, we have to use the formula of 4 over 3 pi r cubed, taking this as a radius, and the mass is given. So it's possible to find rho value. This mass times the volume is equal to this one. The other one is specific gravity. After we find rho value, divide with the rho value of the standard, which is for water as 4 degrees Celsius. Because the solution is here. This is the solution. Mass over volume. Mass is this one, and volume is can be calculated like this: 4 over 3 pi r cubed, because it's a sphere. The volume of a sphere is 4 over 3 pi r cubed, and pi is 3.14, and radius is 0.1, and the power of 3, which is 4.18 times 10 raised to minus 3 meter cubed. So this is it. And specific gravity, we have to take this result, which is rho value for the given wood divided by this water at 4 degrees Celsius, or standard, which is 10 raised to 3 kilogram per meter cubed. Finally, you will get the specific gravity of this one. Okay, so the other thing that we need to see is regarding pressure. We know that pressure is a ratio of force acting on perpendicular surface. So to the area, so pressure is equal to the perpendicular force that is acting on the surface divided by that surface area is equal to the pressure. The SI unit of pressure is Newton meter per meter square, so it is called Pascal. So there is another unit that we measure. You can write like 1 atm, 1 atmospheric pressure, which is approximately 1.3 kilopascal, or it is 1.013 times 10 raised to 5 Newton per meter square is the unit. So this is the formula for pressure, which is perpendicular force divided by area, is the simple formula. Okay, so the other thing that we need to know here is regarding the pressure produced by a column of fluid, and consider the height is h. So the pressure is equal to rho gh is the pressure of the fluid, and sometimes this is called the the gauge pressure. So it's written like the gauge pressure is rho times g times h. So this is a simple formula that we get from these two. So we have a different example. Before that, we have to consider this important. The 3 important points that we need to consider is, okay, all points at the same level in a fluid have the same pressure. So this is one of the important points. The other important point that we need to consider is fluid pressure increases with increase in depth of the fluid. So when you go down to the ocean, the fluid pressure will increase, the gauge pressure will increase when you go down. But for atmospheric pressure, when you go upward, the atmospheric pressure will decrease. So fluid pressure does not depend on the shape of the container. There is an example. Let's take this simple diagram. So from this, this is the same constant rho, the fluid contained constant rho, so they are at the same height as we compare to this one. So when we check the pressure at point A, let's call it PA, the pressure at point B, PB, and the pressure at point C considered to be PC, and this one is PD. So when you compare these pressures at point A, B, and C, they are equal. Whatever the shape of these containers are, the pressure at A is equal to the pressure at B is equal to the pressure at C is equal to the pressure at D. So they always have the same pressure. Okay, so in reality, the picture is just like this one. In a laboratory, you can get such type of instruments in order to see the pressure with different shapes. Okay, the other thing that we can see in this diagram is the pressure. When you go upward, the pressure decreases. When you go downward, the pressure increases. And this can be shown by the fluid which is moving in the horizontal direction. This one, the fluid that comes out from the lower one, have a large horizontal distance, and the middle one is small, and the last one, the fluid that comes out from the top, near to the top surface, it has a very smallest distance. So when you compare this one, because of the change in the pressure, we have a change in the values of horizontal velocity. So because of the change in the horizontal velocity, we get a change in the values of the horizontal distance. So this can be observed in practically in such type of retaining wall. So the pressure for if this retaining wall holds the water, at lower point we have a larger pressure, at this point we have a smaller pressure, therefore the pressure at this point is larger than the pressure at the higher point. That's why we have a different thickness of this retaining wall. Okay, now let's proceed to the next one, which is about the atmospheric pressure. The atmospheric pressure is the pressure due to the weight of the atmosphere, so exerted on the surface of the earth. So the atmosphere itself, which the atmosphere contains different molecules like oxygen, nitrogen, hydrogen, blah blah. So this has its own influence on the surface of the earth. So the influence of these molecules on the surface of the earth is represented by the atmospheric pressure. So the atmospheric pressure decreases when we increase altitude. So when you go upward, the atmospheric pressure will decrease, but when you go down near to the surface of the earth, the atmospheric pressure will increase. Okay, the other thing that we need to consider is the gauge pressure. So the gauge pressure is the difference in pressure between a system and its surrounding atmosphere. So the pressure of the system minus the surrounding or pressure of the atmosphere will give us the gauge pressure. And here is the formula. The formula is this one: the gauge pressure is equal to the system pressure minus the atmospheric pressure. But if you are asked to find the system pressure is equal to the gauge pressure. Take this one to the left side, it becomes the gauge pressure plus the atmospheric pressure. So the gauge pressure plus the atmospheric pressure is equal to pressure of the system. Okay, so the gauge pressure can be read by the instrument. Let's show you the instrument. This is the instrument that measures the gauge pressure. So you can use this for measuring. So this is an example of widely used type of gauge pressure. So there are also other measuring the pressure measuring instruments, but this is one for example that helps us to find the gauge pressure. Okay, the other thing is regarding the gauge pressure. So we have a positive and a negative sign. So look, as we have seen in the formula, the gauge pressure is pressure of the system minus the atmospheric pressure. So the gauge pressure is positive when pressure of the system is higher than the atmospheric pressure, and the gauge pressure is become negative when the pressure of the system is lower than the atmospheric pressure. So let's go back and see the formula. Pressure of gauge is equal to pressure of the system minus pressure of the atmosphere. So this gauge pressure become positive if this one is greater than the atmosphere. If pressure of the system is greater than the atmosphere, the gauge pressure become positive. If pressure of the system is less than pressure of the atmosphere, in this case the gauge pressure is negative. So from this you can understand that the smallest possible value of pressure of the gauge is equal to minus of pressure of atmosphere. When this system pressure becomes 0, that will be considered as the smallest gauge pressure. So these are the instruments and the instrument, the operation of the instrument. One is because of this gear, and the other one because of the elastic property of this material. So by the way, when this materials is elongated, so it cannot pass the elastic limit. If it passes the elastic limit, the reader may not read the exact value. So most gauge measurements most gauge measures pressure relative to the atmosphere pressure as the 0 point. So in most cases, the 0 point is taken to be, or it's equal to the atmospheric pressure. So when the given system has a larger pressure than the atmospheric pressure, so the pressure reader will start to read the pressure that is given to the system. So this form of reading is simply referred to as the gauge pressure. Now let's proceed to the next, which is the absolute pressure. So the absolute pressure, the actual pressure at a given position is called the absolute pressure. It is measured relative to the absolute vacuum, so absolute zero pressure. So the formula for absolute pressure is equal to the pressure of the gauge plus pressure of the atmosphere. This is the important formula that we have. So in most cases, the absolute pressure in fluid cannot be negative, so fluid push rather than pull, so the smallest absolute pressure is 0. So a negative absolute pressure is just indication of a pull, but we know that the smallest possible gauge pressure, this smallest gauge pressure is equal to minus of the atmospheric pressure, making the absolute one is 0. So it becomes the pressure of the gauge is equal to minus of the pressure of the atmosphere. So this is what we have regarding the pressure of the gauge and pressure of the atmosphere. Okay, so the other one that we have is the vacuum pressure. It's the pressure below the atmospheric pressure, and it's called vacuum pressure, and are measured by vacuum gauge. That indicates that the difference between atmospheric pressure and absolute pressure. So pressure of vacuum is equal to pressure of atmosphere minus the pressure, the absolute pressure. Okay, so in order to describe this vacuum pressure, pressure of atmosphere, pressure, so we can have this diagram. I'll show you the diagram. Here is the diagram. And so from this diagram, let's see this line. We have two line. This one is the first line, and this one is considered to be the second line. So at this point, the absolute pressure is taken to be, at this point, is taken to be 0. So when you go upward, there is an increase in pressure. So up to this point, up to the atmospheric point, we have a change in pressure. So below the atmospheric point, we have two pressures. One is pressure of vacuum, the other is pressure of the absolute pressure. So now just leave this one and let's consider only this diagram, only this one. So in this case, the absolute pressure is from this point up to the point A. So the absolute pressure is equal to this pressure from here to here, the pressure of the atmosphere plus the gauge pressure. So the pressure of the atmosphere plus the gauge pressure is equal to the absolute pressure. So if you want to find pressure of the gauge is equal to the absolute pressure minus pressure of the atmosphere. Pressure of the gauge is equal to this one, the absolute pressure minus pressure of the atmosphere. So you consider like this one is Z and this one is X and Y. So Z is equal to X plus Y. So X is pressure of the atmosphere, Y is pressure of the gauge. So pressure of the absolute pressure is considered to be Z. So this system, if you consider this for a given system, this system has a pressure greater than the atmospheric pressure. But in the right one, in this one, we have the atmospheric line. So this point indicates a pressure of a system which has a pressure less than the atmospheric pressure. So in this case, if you want to find pressure of the vacuum, which is equal to, from here to here, we have the atmospheric pressure. When you subtract the absolute pressure, finally you'll get pressure of vacuum. pressure of vacuum. So pressure of vacuum is equal to pressure of the atmosphere minus this value. Pressure of the absolute will give you the vacuum pressure. So PABS, P sub ABS means absolute pressure, P sub ATM means atmospheric pressure, P sub vac means vacuum pressure, P sub G is gauge pressure. So this will describe all, and this can summarize the all points regarding vacuum pressure, absolute pressure, and pressure of the atmosphere. Okay, so having this in mind, now let's go to the next slide. The next slide contains an example and says that a submerged wreck is located 18.3 meter beneath the surface of ocean of the coast of the South Florida. So determine one, gauge pressure, the other is absolute pressure for scuba diver who is exploring this wreck. Know that this one 1025 kilogram per meter cubed is it is the raw value for the ocean, raw value of the ocean. As you can see, it is a little bit larger than the water at 4 degrees Celsius because of the content, salty content of the fluid in the ocean. So so this is the raw value. So actually in reality there is a change in the values of raw when you go downward. So so approximately you have to take this one, and it's possible to find the gauge pressure. So the gauge pressure is simply is equal to rho times volume rho times multiplied by the acceleration due to gravity multiplied by the height, which is the h value, the height of the fluid, or the height below the surface, the h value below the surface of this ocean. So below the surface of the ocean that this diver is present is at 80.3 meter. Therefore the gauge pressure is equal to the raw value, which is 1025 multiplied by 9.8 meter per second square multiplied by h value 80.04. Having this, it's possible also to find the absolute pressure. The absolute pressure is equal to gauge pressure plus atmospheric. Here is the solution. So the gauge pressure is rho gh, which is 1025, which is raw value of the ocean, and g is the acceleration due to gravity, which is 9.8 meter per second square, and h value 18.3 meter. Then finally you will get this much kilopascal of pressure of gauge. So the absolute pressure is pressure of gauge plus pressure of the atmosphere, and it becomes 2.84. so we can simply add the two together, and finally we get the absolute pressure. So the sum of the pressure of gauge and the atmosphere. So this two is the real pressure that is applied on this diver. So the following picture actually shows the wreck, and this is the diver that we see, and this is the ship, and so this one shows wreck and the diver. Okay, so the other thing next to this one, get the Pascal principle. From this diagram you can understand the Pascal principle. So this allows a small force applied to a small area, and so we know that at this point when we apply force, and when this force is divided by the area, it gives us the pressure. So the pressure is transmitted throughout this fluid. So the pressure transmitted throughout this fluid, which means the pressure that is present at this point is equal to the pressure that is present at this point. So if this, consider this one is 1, which is pressure 1, let's take this one is pressure 2. So pressure 1 is equal to pressure 2. Pressure 1 is force 1 over area 1. Pressure 2 which is equal to force 2 divided by area 2. So this with this we can easily find the unknown values. Sometimes area 1 and area 2 will be given for you, and you are required to find maybe F2 by having the values of F1. Okay, let's proceed to the Pascal principle. It states that the pressure applied to the confined fluid in a container is transmitted equally. The pressure that is applied in this fluid transmitted equally to all regions of the fluid. every region of the fluid and to the walls of the container. So whenever you check every wall of this container, you'll get the same pressure. So an important application of the Pascal principle is the hydraulic press, as we have seen in this diagram and the previous diagram. It is best example of the hydraulic press. Okay, the other important thing that we need to consider is in the value of change in x1 and change in x2. So you may sometimes ask to find the values of change in x2. We apply force if area 1 is known, F1 is known, and area 2 is known. F2 is known and area 2 is not known. So you will find area 2 by applying this formula. So the other one is, if you want easily find change in x2 first, you will be given this change in x1. So the thing that you need to consider, or the value that you need to consider, is the volume of this one, the volume of this displaced liquid, displaced fluid, is the same as the volume that's displaced in this direction. So we have to take volume 1 is equal to volume 2. So volume 1 is equal to volume 2. So if volume 1 is equal to volume 2, volume 1 is equal to area 1 multiplied by change in x1. Volume 2 is change in x2 multiplied by area 2. So these two are equal. So divide both sides by area 2, change in x1, area 1 divided by area 2 is equal to change in x2. So with this, it's possible to find the values of change in x2. Okay, the next one is the application of Pascal principle, the hydraulic motion. So it can be applied for in lifting of a car or lifting heavy loads like this one. It can be used for lifting of heavy objects. The second one is just to punch a hole in metals. We can use the hydraulic motion, and with hydraulic motion we can have a different size of hole. And the third one is for bending or molding purpose. As you can see here, this is a metal sheet, and then inserted to this molding machine. Then finally we will have such type of shape. This is the shape that is produced from this machine. So it can be used for bending or molding purpose. Okay, so the next hydraulic lift has an area of this 1 meter square. A car weight is this one on a rack mounted on the large piston. So the large piston has an area of this one. So how large force must be applied to a small piston? So the question is regarding F1. As you have seen in the previous slide, F1 is the force that's applied in a smaller area, F2 is in larger area. So this is a smaller area and this one is a larger area, and a car weight, which is considered to be F2, this is a larger load, weight is equal to 1.10 times 10 raised to 4. Therefore now we have to use F1 over A1 is equal to F2 over A2. Therefore F1 is equal to F2 multiplied by area 1 divided by area 2. So area 1 is equal to 0.2, area 2 is equal to 0.9. Here is the solution. So just take, this is F1 area 1, F2 area 2. F1 is unknown, so F1 is equal to F2 area 1 divided by area 2. So area 1 is 0.2, the smaller area. Area 2 is 0.9. So 0.2 over 0. Just take a correction. This is wrong. So 0.2 should be written here. So the result should be 1.2 times 10 raised to 4 multiplied by 0.2 divided by 0.9. And it will give you around. And so now, okay, the next one is the Archimedes principle.